Here is part 1. The purpose of this project was to send commands using a serial terminal to the microcontroller and vice versa. Not many parts were required to allow this circuit to work. The purpose of this system was to communicate with the computer via UART communication. The PLL.C file utilizes the onboard crystal to enable a clock and set the bus frequency. This module is required to use timers and effectively in the grand scheme of the project. The bus frequency is set to 50 MHz. All timers and interrupts on this project will use this designated frequency. The UART.C file sets up and enables the UART connectivity on the TM4C. For this lab, VCP receive connects to PA0 and VCP transmit connects to PA1. The baud rate is 115,200, which uses an 80 MHz clock. The length of the data transmitted is 8 bits. UART inchar outputs the ASCII code from the UART receiver module. UART outchar grabs an 8-bit ASCII parameter and sends the data to the UART transmitter module. UART outstring uses UART outchar iteratively in order to transmit an entire string. UART in UDEC receives an ASCII character and converts it into a readable 32-bit unsigned number. UART out UDEC grabs a 32-bit unsigned input parameter and converts it into a readable digit 0 through 9. UART in UHEX accepts an unsigned hexadecimal input and converts it to a 32-bit unsigned number. UART out UHEX grabs a 32-bit unsigned input number parameter and converts it into an unsigned hexadecimal format. UART in string accepts ASCII characters from the serial port and adds them to a string until enter is typed or the maximum length of the string is reached. The UART test main.c file contains the main method that brings all the pieces together. The clock, UART module, and port F are initialized. The string please enter a character RGB is output to the terminal. Then a character is taken in from the terminal and that chosen character is displayed. If R was entered, the red LED is toggled on or off. If G was entered, the green LED is toggled on or off. If B was entered, the blue LED is toggled on or off. If neither of these characters are input, the LEDs remain the same. The portf.c file initializes portf pins for input and output. PF4 is input from switch 1. PF3 to PF1 are outputs that are used for the onboard LEDs. When switch 1 is pressed, an interrupt occurs and the red LED is turned off. The string all LEDs are turned off is sent to the UART transmitter module if the LEDs have been toggled off. If switch 2 is pressed, the string all LEDs are turned on is sent to the UART transmitter module if the LEDs have been toggled on. This video sums up Project 2 Part 1. The project worked as expected and the user was able to send commands using a serial terminal to the microcontroller and vice versa. Switch 1 on the microcontroller turned on all its LEDs and sent a confirmation message, all LEDs have been turned on, to the serial terminal. Switch 2 on the microcontroller turned off all its LEDs and sent a confirmation message, all LEDs have been turned off, to the serial terminal. When characters RGB were sent to the serial terminal, they directly manipulated which LED was toggled on or off. Here is part 2. The purpose of this project was to send commands using the serial terminal to the first microcontroller, and the message will also be sent to the second microcontroller and vice versa. This project needed to accomplish several tasks. First, we needed to connect a potentiometer as a voltage divider circuit to one of the analog inputs on MCU2. As you change the resistance of the potentiometer, it will send the updated analog value to MCU1, updating the brightness of the blue LED and show the ADC value on the computer terminal. Then, we needed to send characters from the serial terminal to MCU1, which then gets sent over to MCU2. We send a character R to MCU1. MCU1 sends character R to change MCU2, which makes the red LED on MCU2 toggle on and off once every second. Once MCU2 LED is blinking, a confirmation message will be relayed to the serial terminal. When we press button 0 on MCU2 to turn off the red LED, a confirmation will be relayed back to the serial terminal. Not many parts were required to allow this circuit to work. All that was required were the two boards, a potentiometer, and obviously a connection to a computer. The UR main.c file for MCU1 contains the main method that puts all the pieces together for the first microcontroller. There is a SysTick timer that is also initialized with an interrupt enabled to occur every 25 milliseconds. When an interrupt occurs, the ADC value from the potentiometer is output to the terminal. This value directly controls the brightness of the red LED. If R is entered into the serial terminal, the red LED will blink and the terminal will output red LED continues to blink. Otherwise, the red LED will no longer blink. In the main method, the PLL, UR, UR1, port F, and SysTick timer are initialized. A super loop is then used to wait for SysTick interrupts. The UR main.c file for MCU2 contains the main method that puts all the pieces together for the second microcontroller. There is a SysTick timer that is also initialized with an interrupt enabled to occur every 25 milliseconds. When an interrupt occurs, the ADC is called and grabs data from the potentiometer. It then sends this value to the serial terminal. If the character input to the terminal was R, the onboard LEDs turn on the red LED. Otherwise, the LEDs remain the same. In the main method, the PLL, UR, port F, ADC, and SysTick timer are initialized. The LEDs are then switched on to ensure they are working. Finally, a super loop occurs where we wait for the input from the first microcontroller. If the input character is R, the red LED is toggled on. The portf.c file for MCU1 initializes portf to use pulse width modulation and enables output on PF2. These modules are necessary to create a blinking red LED on MCU1. This file also outputs character return and new line feed character to the serial terminal. The portf.c file for MCU2 initializes portf pins for input and output. PF4 is input from switch 1. PF3 through PF1 are outputs that are used for onboard LEDs. When switch 1 is pressed, an interrupt occurs and the red LED is turned off. The string red LED turned off is then sent to the UART transmitter module. The ADC file converts an analog signal into a 12-bit digital signal. PF4 is used as the input source. Channel 9 is used with sequence 3. This means the speed is 135K. PE4 comes from the in-circuit potentiometer and the analog value from this component converts into a digital signal. The digital signal is then sent to the main C file to be used in the system. This video sums up Project 2 Part 2. The system was able to let the user send commands using the serial terminal to the first microcontroller and have the message also be sent to the second microcontroller and vice versa. When character R is sent to MCU1, MCU1 sends character R to change MCU2, which makes the red LED on MCU2 toggle on and off once every second. Once MCU2 LED is blinking, a confirmation message, red LED continues to blink, is relayed back to the serial terminal. When button 0 is pressed on MCU2 to turn off the red LED, a confirmation message red LED turned off is relayed back to the serial terminal.